All right, so real quick, let me get through these guys, and then we'll have time at the end here. All right, so again, you got some curve, it's just some stuff, and then it says, see, and like, do you see? Check this out, Chris. Very interesting how they did it. Do you see how they said show that dy dx equals that? It actually gave you the answer. Why would they do that? Does anyone have any idea? Simon.
They're not looking for if you can find the answer, but if you know the process.
Yeah, so that's what they're going to score on that one. And not only that, they want to use it in the other two questions. So if you didn't get that, how could you even start getting any points on the rest? You're done. You know what I'm saying? So what they did here was they gave you the answer so that even if you were like, what? You have a derivative, and then you can answer this question with it. Do you see that, you guys? Does that make sense? Okay. So then, okay, yeah, so show that. So we're thinking implicit differentiation here, and then were we all good there? How do we do on that one?
Yeah.
Okay? So again, 2 points. 1 point you guys just for doing it, just for going straight across. And then 1 point for then solving for the y prime. So two good points, 2 multiple choice questions. It's great. Okay, show that there is a point P with x coordinate 3 at which the line tangent to the curve at P is horizontal. Find the y coordinate of P. What the heck is that saying? What information can you get? What did you guys do? Here's some scoring stuff. But what does all that mean? Show that there's a point P with x coordinate 3 at which the line tangent to the curve at P is horizontal. Where's the calculus in that? What is it saying? Telling us to do? Right, looking right here. Line tangent to the curve is horizontal. What is that asking us to do? Yes. You know what I'm saying? So even, is that even a point? Yeah. If you do that, you get a point. You know what I'm saying? Just recognizing that. Even if you just like don't go anywhere from here, just recognize it. Well, all of this nonsense says, okay, this is a bunch of gobbledygook. It says, wait a second, tangent line. I know what tangent line is. Horizontal means slope is 0, so I need to set that derivative equal to 0. If you just do that, without doing any other work, you got yourself a point, Sandy. See what I'm saying? Okay? And then you got to actually solve for it. So when does a fraction equal 0? When the numerator equals 0. So then that's why they did this here. Or, what you could do is multiply both sides by the denominator, and it would be gone, because you multiply by 0. And then you're stuck with this. Well, from here you wouldn't know what to do. You can think of maybe combinations, but it told you x is 3. And that's what you need here, and then you can solve for the y value. Okie dokie? So this is the point, the 3-2 point is where the horizontal tangent. But then it also says, this one, yeah, show that there is a point P. Well, you just solve for some random x, y, and then here, what they did was they plugged it back into the original equation to show, like, how do you prove this is a point on the curve? You know what I'm saying, you guys? Because what you just did was, you solved for a y value in the derivative. Hopefully that point was on the curve. You know, you could always just solve for y value, because maybe there's no place where it's equal to 0, or when x is 3, you know? So what we did was we solved for an xy points, like xy values, for the derivative equal to 0, but this has nothing to do with actually being on the original curve. So what they did was, they plugged in x and y to the left and to the right, and since they were equal, it is a point on the curve. And that extra little guy got you the third point on that one. Showing that it's on the curve. Because just solving in the derivative piece for that y value doesn't prove it's on the curve. It's just some random y value. But by checking it, now you got it. Alright, so then the third one. Or C, okay, it just says find the second derivative at the point, at the same point. Okay, so you go through all the algebra, and I heard these guys say yesterday, like, you don't want to waste it. So it is a bunch of stuff. But the good part is, and then it says, does the curve have a local max, min, or neither at that point? Okay, so you do a bunch of stuff. And you get this second derivative. You get this. Okay, so like now that is done, and it should be a point. It's 2 points. Great. You get 2 points for doing that second derivative. You work your way, you take your time with all of that algebra that you don't want to do. 2 multiple choice questions. Great, you know? Okay, so then, how do you solve your way through it? Well, here it just takes, we have a bunch of stuff. What we've been doing is we've been taking the y prime out and putting what y prime is. And you see how even messier that would be, specifically without a calculator? Well, what they did was, at that point, at the point 3, 2, the derivative was equal to 0, yes? So they just plugged in that value as well. So I didn't really see an x and a y. They plugged in the 3 and the 2. That's 0. This thing was 0 from before. This would be 3 times 2 minus 2 times 3. So then this whole thing is gone. And so that's where these numbers come from. It's just this first part. That's equal to 0. That's why it's just negative 2 there. They plugged in there. Okay? So just plugging in the values got you another point. And then how do you prove it? You got negative 2/7. And then how do you prove that's in a min or max? Well, it is a critical point. The derivative equals 0. Second derivative is negative. It's concave down, which makes it a max. And just having this and this got you a point. Okay? And again, that's the second derivative test. That's something that's going to be on the Chapter 4 test. If you need to prove a min or max, there's the first derivative test and a second derivative test. First derivative test is where y prime equals 0, and then it's changing sign on the derivative from positive to negative or negative to positive. That would give you a min or a max. The other one's a second derivative test. The first derivative equals 0, and then it's either positive or negative concavity will tell you if it's concave up or concave down. A min or a max. Okay, those are the 2 tests. Cool on this one, you guys? Again, a lot of points that you can earn. So this one was just a lot of legwork, but definitely a lot more straightforward than a lot of the other questions. Yeah?
So d squared y over dx squared is the same as y?
Double prime. Yes.
Okay.
Yes, exactly. D cubed y over dx squared would be the y3. It's the 2 different notations. Alright, next one. Was there another one on the 04? I got it written over there. Was there another one on the 04 or was it straight to the 05? It was 4 and 5 on the 05?
Yeah.
Okay. Exactly. Okay. So I saw a lot of people did good. I saw a nice little shark fin. And what number was it? B and D? Or A and
A and B.
A and B, okay. So you got all of this information. We have original function values. You have derivative values and second derivative values. And it says final values for x has a extremum. What are we looking for when we're looking for extreme values? Or undefined, okay? And not only that, those are your candidates for critical points. Critical points are the places where you can have a min or a max. In order to then have a min or a max, what else has to happen? It has to what? It has to, the derivative has to change sign. So in this case, if we look at that derivative, it does equal 0 at 1, and it doesn't exist at 2. But it stays from positive to positive. So that's not an extreme value. It does change at 2 from positive to negative. Since it goes increasing to decreasing, that's a maximum according to the first derivative test. So that would get you 2 points. 1, just to acknowledge the 2, and then the other one was relative maximum min with justification. So if you said, I would assume that you would get 1 point if you said 1 and 2, and then did your justification for 2. You wouldn't get the first one, you would get the second one. Does that make sense? That you'd be, if you thought, with the derivative equal to 0, that would be an extreme value. If you then went through the justifications why, you'd get the second of the 2 points, but not the first.
Why wouldn't x equals 0 be a relative min?
Look at the graph.
Oh.
Isn't it like a... Oh.